Okay, so I'm Ulrich Lang, and I'm presenting about securing secure complex cyber-physical systems. So this is around industrial Internet of Things, and this is kind of a case study session. So I'm presenting a few clinical hospital-type device examples, but the talk as such isn't restricted just to clinical. It's just examples for IoT, right? So you could also call this talk security policy automation. So I'm talking a lot more about the policy. I'm not really going to talk about the identity part, more about how to enforce policy. So you could also call this talk, let's talk better access control, right? Now that's all part of IAM, but might be of interest. So the overview here is, first, gonna just intro the whole thing, then talk about what cyber-physical means and why it's interesting for us as a security profession. Then I'm going to quickly introduce smart healthcare. And after that, I'm presenting 3 case studies. 2 of those are going to be about IoT. And then there's some conclusions. And their slides should be already available. If you want the slides, it's just objectsecurity.com/CIS 2017. You can download them there. But this will also be recorded and be available later. Okay, so about myself. This is the hat, by the way, that I lost. So if anyone found this hat, I don't know, party was good last night, I guess. So yeah, I'm the CEO and co-founder of ObjectSecurity. We're access control guys, really. I have a PhD in access control from University of Cambridge and a master in info security. So I guess I've kind of been around the block with this for a while. And I co-invented a product called OpenPMF. So this is an access control product that does this thing that we call security policy automation. We're really, as I mentioned, we're not a healthcare company per se, a healthcare IT company. It's just one of the verticals that we do. So you can apply all this to any kind of device-rich kind of environment. So why is cyber-physical a topic here? Why is this actually interesting? So this is the NIST definition. What is it in the first place? It's interacting networks of physical and computational components. They like to say it in a mouthful, I guess, but what it means is essentially that the physical world is impacted by the IT stuff. So sensors, actuators, everything's moving. So smart city, smart grid, intelligent transport, smart healthcare, all that, right? So this is a foundation for critical infrastructure and for smart business, future smart business, smart services. And the goal here is often to improve quality of life through automation and things like that, right? I just mentioned a couple of examples. So the buzzword is Industrial Internet of Things. IIoT is actually an acronym, right? And why is it interesting? Because cybersecurity impacts physical safety. So I did a project a while back for FAA, just to illustrate that point, and they didn't really care that much about the cybersecurity part per se. Because, I mean, the flight plans are kind of public, and you can track the aircraft online. They were mostly interested in, does the cybersecurity impact safety, physical safety, and where, right? So at that point, you're talking about this whole issue of selling security is an easy sell, because now we're not talking about some arcane selling insurance kind of thing where it's maybe a financial loss or not. Now we're talking about harm to people, right? So this is why cyber-physical, if you're trying to sell security, if that's the case, that's the hardcore markets where people can't get around security. They have to do it. So looking at, just still to intro the topic at smart healthcare, which is partly IIoT. So why? Because hospitals keep telling me it's to improve patient care and efficiency, so the quality of the experience for the patient, efficiency, and so on, right? So when you look at that, what they have is they have a lot of devices. They already have those today, but not very interconnected. So these will be networked, smart, semi-autonomous devices like infusion pumps and blood pressure monitors and so on, right? Everything's talking that's relevant, clinical, business, and building systems, right? Everything's going to be connected and sharing information, so everything's more efficient. Real-time data analytics and tracking. and automation. So the cost savings is in fact pretty significant for hospitals when they do this kind of stuff. But you need better cybersecurity to make that happen. So now cybersecurity, again, isn't like selling insurance, it's an enabler for this future business, right? So now going into these case studies to illustrate kind of I guess, if you will, a couple of topics that crop up. The first one is just an IAM roadmap, and we're not really identity consultants. So why did we do this for a hospital? Well, mainly to educate them about the topic and to explain a need to them where we already had identified the gap for better access control and security policy automation. That's a pretty painful way of doing business, so we go a lot more frequently through channel partners than us handholding the customer into a roadmap so that they finally realize they need what we have, right? But that's the reason why we did this. And what we found in this IAM roadmap was there are a bunch of complexities in hospitals. For a start, the IAM is distributed, so there's usually one main IAM. It's very often Active Directory and what hangs off that, right? But there's also numerous sub-IAMs, so you have particular medical devices, the expensive ones, that have their own IAM, and you have to onboard and offboard people to those particular devices, and it doesn't all come together yet in some real-time integrated provision-deprovision system, right? There are custom batch processes to make that happen. Some of them is manual too. So onboarding, offboarding involves manual work, at least at that customer was for sure. There were limited checks, especially for offboarding. I'm sure you've all seen that onboarding, you know when it didn't happen. Somebody's going to complain. Offboarding, well, stuff lingers around, right? There was almost no workflow automation. That meant inefficiency, and this just because everything's been sort of ad hoc evolving. There was a flat network, quite flat, so there was a lot of attack surface all over the place. There was little isolation, including cyber-physical, like the HVAC systems and so on. They would actually be relatively exposed. And closer to my interest, there was really no fine-grained access control. It was non-existent. It was the user login to a system or an application kind of login, and you had roles, and the roles had permissions in, say, the EMR. So it's been kind of, we did actually spend some time there and wrote a report, and you can see the diagram there. There were some gaps that we identified. Interesting, I'm going to take this laser pointer now. If I click on this, you see the policy part that we looked and put in their roadmap was the least developed part here. So you've got access control here, and this actually down here too. In all of the different topics that we identified, that was really the missing piece, how to manage that. It was often built into the applications somewhere ad hoc, right? So that was an issue. So the main challenges were ironically not technical. I mean, there's a lot of IAM guys here, you know how to do this stuff. Well, in reality, when it's too many cooks stirring the pot, you do have immense problems, and that was really the problem. Oh yeah, let's stay here. So really, was very challenging environment politically to get anything done. So let's close up on access control, and then we're homing in on this whole IoT part. So the access control and just general control wasn't good enough and isn't good enough in hospitals, for example. So 25% of all hospitals had at least one HIPAA-relevant breach, right? There's over-provisioned access in many places, and you've seen the Mirai and WannaCry, they both also attack medical devices, so that's a bit scary. And access control was too simplistic. I mean, this is what happens when you have an identity-centric view on access control. You end up with very simple access policies because you're having often user granularity, and if you're lucky, you got RBAC, role-based access. Often it's just IBAC, identity-based, right? So the user password type thing, or two-factor or whatever, and it was fragmented and siloed. So that's all challenging when you're looking at what HIPAA says is much closer to a least privilege kind of policy that needs much more contextual, fine-grained access, right? So better access control needed to prevent fines. So there's been HIPAA fines up to close to 5 million for hospitals. That's rare. So I'm not trying to scaremonger here. And smart business is forecasted to save each hospital that implements this 8.5 million a year. And that's not really out of the ordinary when you look at RFID-based tracking of devices, the kind of efficiency gain when devices are utilized better. These are like $1 million devices, some of the stuff, right? That pays off after a while. So I want to throw in attribute-based access control. It's kind of been talked about and been coming and going, and it's kind of in the back of people's head. Maybe part of the solution, depending on how you define it, I guess. So Gartner says 70% of organizations will use it by 2020 in whatever form, but it's often, we've been doing this for a long time, it's often hard to manage and author policies and hard to implement and integrate the solution to actually get enforcement, right? And it's also hard to audit. It's one thing that people don't really realize is once I start having contextual, fine-grained policies based on many factors, I will not just be able to do a role review when I want, because I don't know some of the values that will determine the policy up front, right? So do you see what I mean? So if it's environmental dynamic context of some sort, like who's to do, which relationship between some, say, patient and nurses and so on, that changes dynamically, so you will not be able to just click a button and say, what's the effective access of Ulrich right now? It's challenging. It's possible, but challenging. So let's look at this quickly. So when you look at RBAC, you could kind of take this example here. Nurses can only access medical records of patients, right? So that's kind of like the role and the resource, right? When you transition this to ABAC, you have a lot more attributes. So these are factors that play into the policy. So I just made up an example that isn't meant to be realistic. It's just illustrating the point where you say, so nurses can only access medical records of patients whose current treating physician is the same physician who the nurse is currently assigned to assist, right? So you're restricting the access, and only if the nurse is currently badged into the same physical building as the one the patient is. So now you're restricting it contextually even more. That means you got more granular access, you don't over-provision so much. That's sort of the idea. Now, as you can see, I kind of marked a few things in blue. It's not coming out that well, but these are all attributes that you gotta have a data source for. You gotta know what those values are. You gotta dig those out for every decision. So this is where the complexity crops in, right? It's all nice in theory. In practice, you gotta really know what you're doing to make that happen. All right, let's look at now the term that I've been using and not really introduced yet, security policy automation. We've also called that model-driven security in the past, but many people call many things model-driven security. So I prefer security policy automation. It's more descriptive. Why would you want it? Well, because it will allow you to actually manage powerful security policies that are also intuitive and generic to author. So basically more effortless to manage and also more consistent and testable. So how's it work? What is it anyway? So the basic idea, very basic idea is you author policies in generic terms. Think of like rules with wild cards where you say, I want this kind of information fill in here and this kind of information there and this relation between nurse and patient and doctor, I want to keep very generic and then fill in values that go on each device, for example, depending on which doctor and which nurse should access which device, right? That's the kind of thing. So you don't have to say this, you just say this generic stuff in general terms, right? And the policy automation part imports information sources from network traffic, application traffic, EMR, ERP systems, whatever you can get your hands on, identity management, existing identity management, right? And brings it onto a consistent, if you will, data layer, a consistent data format, so you can essentially analyze it and fill in those details, right? And then what pops out at the bottom is technical rules and configurations for whatever systems you have, right? So you may, and this may be on many layers, you may have host firewalls where you want to do IP filter, IP tables or Windows firewall, and you want to configure those to whitelist certain things in line with your policy. Well, you should push that out from a consistent policy without you having to deal with, is it a Windows box, is it a Linux box, what's the format, how do I say it, everything. That should be done by the system. So that's security policy automation. It essentially inflates what you want into all the technical details for numerous platforms and systems and distributes it. And there's enforcement too. That's where it overlaps with ABAC. ABAC usually has a runtime enforcement component that acts kind of like a firewall. So there are many steps that can be part of this. So what we where we structure our thinking about policy automation is in 8 major steps here. So the first one being analyze and visualize. That's the information that you're bringing into your system, because this all, as I mentioned, all of this ABAC depends on the quality of the data of what you feed into those values, right? You're basing your decision on data, basically, quite often. So then you can import existing policies if you have any, and also bring those as a sort of baseline into your product, and then author your policies. So that's the big chunk where you have to essentially state your policies in as generic as possible terms, so you get reuse and things like that, right? So there's real benefits to do that. Then you generate the matching enforcement, and in the process now, because you're using this model-driven approach that's akin to model-driven development, but for policy, right? You can automatically document compliance because you're using an automated process, right? This typically is a manual process in most organizations, right? We automate it, so we can automatically document compliance, so it spits out reports. You can enforce it on the runtime, whatever. We have some enforcement runtimes. So every ABAC vendor has their own runtime enforcement. These often interoperate also, right? So you can build an ecosystem of enforcement. You can monitor what we call policy violations, which are essentially incidents where you can be as aggressive as you want. So we're pretty aggressive usually, and flag everything in an IoT environment, flag everything that wasn't explicitly allowed and was therefore blocked. So if it's blocked, it's already an incident. But that depends on your network. If you just have a lot of noise anyway, you can't do that, right? And then update and customize. That's an interesting aspect here when you're looking at this picture again. You can essentially round trip here, but if your imported information changes, if your policy doesn't, you just import the changes, or it calculates the changes and updates the enforcement, and that way you can support a level of agility in your interconnected device landscape that you wouldn't get otherwise. Because if you change something otherwise, you would need to manually change all the rules and configurations that you have, right? So that's the idea. So that's the policy automation part, which we actually now get into the deployments for. It was intended also to go into that hospital, but didn't make it there in the end for all these political reasons that I mentioned. So a very interesting project we've been involved in through a prime contractor, and it was for DARPA, around smart ICE. ICE is integrated clinical environment. So DARPA is actually funding work there, where there was a middleware environment that was like a shared data space, pops up middleware, kind of like very elegant way of plugging devices together, and there were infusion pumps and patient monitors. So it was kind of a mock-up environment of a smart hospital room where you don't have the nurses do everything, but things automatically happen and checks are done and so on, right? Won't go too much into the detail. All these things basically talk, all these devices, right? And what we did is we put our policy automation, this generation tool, if you will, on top of this to author, test, and document policies, right? So there were 2 ways of doing it, and we, in fact, decided to do both just to see what's better. One of them is to use our own software agent. So we have a software agent that ties into this DDS middleware and automatically intercepts, in this case, the startup, the initial discovery phase, if you will, of how devices find each other based on what information they want to get or publish, right? And then enforces the policy there. So that's the one way. The second way is we actually export it. And there's a reason why we did both. Won't bore you with it, but we export it into this standard that's being finalized by the Object Management Group for DDS security. So there's an XML permission file, in fact, that they have where we build the policy automation automatically generates this XML file for you. You just dump it on each node, and it'll automatically enforce that policy, right? So what were the challenges here? Challenges were the process to determine the policy in the first place was very hard because hospitals aren't quite as process-driven as you would think. So it's not like FedEx or something where it's top to bottom is kind of a known process. It's a lot more loose, especially the higher up in the pay grade you go, the more it's kind of, I'm looking what needs to get done, right? So that's hard when you're looking at automating policy, fine-grained access, right? Then we have dynamic changes. The devices move around all the time. That's part of the challenge as patients get lugged around from, I don't know, like the operating room into the ICE and so on. Devices don't often move with them. They get reconfigured, but sometimes they move, and it's just complex, right? And then you got HIPAA policies. They are complex. Another complexity that we found is how to wrap legacy devices. So you obviously have pretty much all of the patient monitors or any of these devices are existing, and they aren't intended to be plugged together like this, right? So there was a challenge of getting the agent onto this, right? We did have solutions for that, which I'm going to come to. Interestingly, part of why DARPA funded this was to use the SEL4 microkernel. So that's a high assurance microkernel operating system with a formal mathematical proof to be, for a start, secure according to those specifications, and also to have upper guaranteed boundaries on bounds on some certain whatever calculation things. So it would, for example, not deadlock or freeze or something, right? So they wanted to use that as the test environment, right? There's also the problem of a manually specified application model. So one of the inputs that went into policy automation was that we actually modeled this, what devices are there and what interactions. That's very unrealistic, obviously, right? So here's a very simple example. I don't know why there's arrows there. So here's a high-level policy that was used. You can see those wildcards in our, if you will, constrained natural language editor. We have those just like you have them in your command line, you know. There is a way of saying which set of information you want to tie into this to inflate policies, basically. And as you can see, it's been a trivial policy. So this is just the publisher, the topic, the domain, subscriber, topic, domain. These are essentially the way DDS figures out what data gets published from whom to whom. So this is a trivial policy in this example. And we generate the low-level policy from there using policy automation, feeding in all this information that we have. Then we sort them by decision points. So in our environment, decision points and enforcement points are on the same nodes. We don't have central decision points typically because we don't like that for performance reasons. So we sort all of this, what rules, which ones of the access rules pertain to which device, so that we can then push them out, right? And we then have those two ways that I mentioned to push the rules either in our own runtime or using those XML files. We also generated, and this is interesting, underneath the whole thing, we generated IP whitelists, IP port whitelists using IP tables. The host firewall, right? Based on the same policy, because that shows already the value of security policy automation. You didn't have to say anything here specific about, is this IP to that IP, I want to whitelist it. Instead, the system already figured out that a particular publisher that a rule gets generated for is already on that IP address. It knows, it detects it as part of the imported information. That you can say there is a publisher on this IP address and a subscriber on that IP address, and this one's talking this topic to that topic. We already fed that information in from the running system, the unprotected running system, if you will, right? And use that automatically to generate also IP whitelists. So you could generate many more things here. At some point, you would need to improve the policy to add certain features, because this is obviously not a rule that resembles anything like HIPAA has with the security and privacy rules. So it's a very trivial example, but it illustrates the point of policy automation quite well. You only have one thing here, and in the end you have a load of stuff that pops out at the bottom, right? And if you then reconfigure your device landscape, these details can be automatically regenerated, updated, right? So we are right now in another SBIR with the same company for DHP this time. This is a defense health agency. This is related to Open ICE. There's actually an open source integrated clinical environment platform that some people are building. You can go to openice.org and check it out. So we continue the work there, integrate into this OpenICE and use real access policies that matter for hospitals, right? So not just that trivial rule, real data and a more realistic application. So the application back then was a kind of alarm. If your blood oxygen goes too low, then the alarm should go off somewhere, and you would check if the pulse is 0 all of a sudden, but the blood oxygen is normal, then you know that once again the sensor fell off the person's finger. So these are things where you laugh and think, wow, this cannot be that's a thing. That's actually a thing. Like nurses run around in a frenzy in a hospital because these kind of things happen and sensors aren't integrated. So they think, oh, is the patient dead or is it fallen off again? Well, how do you know, right? So with this, it would be automatically possible for the system to say, well, the patient's obviously there, otherwise there wouldn't be blood oxygen, right? So these are the kind of things, right? And then also we integrated formal policy testing and automatic detection and ingestion of the information. As I mentioned in the previous, the thing that already finished, we manually specified a bunch of information about the system. We want to detect and import pretty much all of that by running, if you will, a clean version of the environment, then analyze all this data using visualization that we have and so on to pick exactly the information flows that we want and whitelist those, right? That makes life a lot easier than manually specifying stuff. Speaking of this formal testing and these two last features, formal testing and automatic detection, we're doing some work, SBIR work with NIST. I'm kind of presenting the cooler stuff here, the SBIRs today, so that you have something interesting. So one of them is, I talked first about the ingestion part. So we're smart merging the traffic, for example, that we can detect. So I mentioned with DDS, there's publisher and topic and so on, right? With network traffic, you know what that is, IP port to IP port protocol, whatever. Turns out DDS isn't that simple. As a middleware, it picks its sending port randomly, more or less, from what I can see, so that it can scale better. The recipient port can be calculated from a calculation that depends on the topic and the domain and things like that. So it's pretty complex. Turns out you can merge TCP dump traffic logs with that and actually infer quite well what this application layer is doing. So you can say strip out discovery traffic between nodes that will subsequently never talk, because you wouldn't need a whitelist just because there is a discovery traffic and later never talks, right? So we import from identity management using LDIF. That works surprisingly well. So you get a bunch of, I guess, asset lists and user lists and roles and things, right? And import existing policies. For example, we import XACML. We import a firewall rule set from actually an open source firewall. We import syslog. So this is, I think the whole thing gets better the more data sources you can import and merge into this, what we call functional model of what's going on. Here you can see a visualization of an environment that we have running in a test bed. The formal testing is based on NIST's, they call it ACPT, it's Access Control Policy Tool. They've spent a lot of R&D, and then we won an SBIR to commercialize the work. So it uses a symbolic model checker. This is essentially a tool that builds a formal finite state machine of your system and then runs through every possible combination that you specify and checks if certain properties can happen or cannot happen. So you can, for example, say, well, if I have this environment that does that, like these information flows, and I have these kind of policies, can this node talk to that node? And it'll run through and give you a proof, yes or no, it can run or cannot. This will not happen or it will happen, right? So that's, we give that to people in our cloud service also as a sort of easy entry barrier, kind of low entry barrier tool where you upload all these imports and then you run the formal test and you get the results and download the report. It's kind of interesting because we managed to take this pretty complex work that NIST has done with they're using, like, it's very bloated what comes out of a formal methods tool, and managed to correlate that back to the rules. So in our tree editor, the rules have like little icons and you can decorate those with something like graphical bits and pieces, right? So it turns out you can actually have crosses and arrows there, that essentially says yes or no. So that the whole thing becomes for a user very easy. If you're already doing policy automation, you just state other access rules as properties you want to test against, press the button, and it'll tell you yes or no. So that's the review part that I mentioned earlier, where ABAC is very hard to review whether somebody has access or something's going to happen or not going to happen, right? That helps you automate it. So that's a lot of information. I leave it at that. When I now just wrap up what we talked about, just to bring everything kind of full circle. Did talk about security policy automation, which is supposed to give you a powerful technical security policy implementation that's actually easy to manage, right? So it's this combination that matters. There's been plenty of talk at this conference that we're talking about users, devices, and applications, not just users. It's actually been our kind of thing all the time. We've always been machine-to-machine people before there was IoT, you know. And it's supposed to be consistent, testable, documented, robust, and repeatable. So these are all things that you don't get when you do this manually. There's no way for you to document everything, every change, you know. We talked about cyber-physical systems, that it's a great use case for cybersecurity and IAM for that matter too, right? Because we're not selling security, we're selling actual physical safety also, right? And that maybe selling, in many cases, sells better, that you're helping keeping people safe, right? One thing we definitely noticed is current customers need education and understanding. So you just can't come in and sell it like a shrink-wrapped category of product, like a firewall, right? Or an identity management. That's a pretty established category that people understand. This thing needs education. So what we found is it's best to go with consulting and integration partners. So we're building a pretty heavy channel program for our company, and we're obviously inviting anyone to contact us. I think that is probably true for anyone that's trying to kind of be a little more innovative and disruptive. You cannot just go to the customer and say, here's this cool thing, when that's not what they're really asking for, and they don't understand they have the pain point, right? Whereas the identity consultants come in and solve a bigger business problem, and they understand that there's a gap that this fills, so they can then communicate that as a package with other stuff to the customer. It's really important. I mean, we really tried every other way also. That seems to be the best one. So I think, in my opinion, and this you can question, but the industry needs to move this way. We cannot manually manage technical policies for cyber-physical IoT, like the large-scale smart city, smart grid, or any of these high-assurance environment where people are going to die if something goes wrong. We just don't have the manpower, and humans are very error-prone. So you don't really want to rely on that. And that really wraps it up. And I think I overran, is that right? I'm not sure. I think I did. But that's it. Thank you. And yeah, do we still have time for questions? So I guess we have 2 questions. Is it okay if we take them? I don't know if there's anyone here that's policing this thing. If not, we just go ahead. I don't know if there's, I have a mic here actually. You want one? If you want to take this.
My question was related to service accounts or non-person accounts in devices. You've talked a lot about the person accounts, the access controls for people, but what about the access controls on the devices themselves, so that if a device gets compromised, the device itself can't hack another device and propagate some sort of adverse effect on a patient?
Yeah, that's actually what the thing that you talked about is actually what the core of this was. We were much less concerned with the user accounts and much more with the device-to-device accounts. So we don't really distinguish that. I mean, these both are supported, but because we're not an identity management tool, and it's just a different access attribute, is device ID versus, or device authenticated identity versus user authenticated identity. But we're seeing, I would say, 80% of the importance is with machine-to-machine identities and not the user. Users often don't even matter. Like we had projects where users don't matter at all, you know. There was another question, I think. Oh yeah, cool, yeah, because I think we're overrun here, right? We're way behind, sorry. All right, thank you very much. I started late because the people were like late from the